In this video, we're going to talk about implicit differentiation, and we're going to find some derivatives implicitly. It'll be in section 2.6, starting with number 5. Number 5 says g of t, sorry, not 2.6, 2.7. 2.7, number 5 says y to the fourth minus y squared plus 7y minus 6x is equal to 9. So now I want to find the derivative. So I can't easily find dy dx by separating my x's and y's and getting a y all by itself and like that, because this is a function that is defined implicitly where I need both x and y to solve it at the same time, or I'd have to solve for x as a function of y, and we don't normally take derivatives in the form of dx dy. So let's go ahead and differentiate implicitly. So y is some function of x, right? So I'm going to be able to think of this as some function of x raised to the fourth power, and to think about the chain rule, that if I have f of x, I'm just going to do this with the fourth one, with the first term here. I'm not going to do this with all of them, but if I want the derivative with respect to x of this whole thing, I'll use the power rule, 4 times f of x raised to the third power times f prime of x. Well, all I'm going to write there instead of f of x is I'm going to write y, and instead of f prime of x, I'm going to write, I think they tell me to use dy dx here. My instructions, yes, they tell me to use dy dx. So every time I differentiate a y piece, I'm going to have a dy dx on the end of it because of the chain rule. So that's what's going on with implicit differentiation. This is for y to the third dy dx minus 2y dy dx plus 7 dy dx. Now notice there's no y's in this term. This is just a regular derivative with respect to x. So that's minus 6. And don't forget the derivative of a constant is 0. So I'm going to go ahead and separate the dy dx terms from the non-dy dx terms by adding 6 to both sides. 4y cubed minus 2y plus 7, common factor dy dx is equal to 6. Going to divide both sides here by 4y cubed minus 2y plus 7. 4y cubed minus 2y plus 7. So dy dx is equal to 6 over 4y cubed minus 2y plus 7. So I can't find the slope here, dy dx, without knowing the y value of the point where I want to find the slope. More on that in the next video, where we're going to find slopes using implicit differentiation. But for now, we're just finding the derivative dy dx. Your teacher may tell you it's okay to use y primes. I want you to get used to using dy dx's according to the instructions in the textbook, because of something that you might do called related rates in a little bit. I think that might actually be the next unit here. Yes. So using dy dx here will get you ready for a related rate problem coming up in the next section. So number 7, xy squared plus 4xy is equal to 10. And so I have a product rule going on here. I'm not going to write the product rule out now. We've done the product rule enough. Derivative of the first part, leaving the second part alone, plus derivative of the second part, leaving the first part alone. And again, derivative of the first part, leaving the second part alone, plus derivative of the second part, leaving the first part alone, and derivative of a constant is 0. So we have y squared plus 2xy dy dx plus 4y plus 4x dy dx is equal to 0. So we're going to subtract y squared, and we're going to subtract 4y to get rid of the terms that don't have any dy dx's in them to get them to the other side of the equation. We have 2xy plus 4x dy dx on the left is equal to a negative y squared minus 4y on the right. So divide by 2xy plus 4x, divide by 2xy plus 4x, and dy dx is equal to a negative x squared minus 4y over 2xy plus 4x. All right, let's look at the next problem, which is number 9. Number 9 says 2x plus y over x minus 5y is equal to 1. So I have a quotient rule going on here with implicit differentiation, but also this one isn't so bad to just multiply by the denominator here and to say, let's make this 2x plus y equals x minus 5y, because 1 times that denominator, and then we have subtract here and get x plus 6y is equal to 0. And so we should have 6y equals negative x, y is equal to negative 1/6x, dy dx should be negative 1/6. Let's see if we get that when we deal with it the way that it was given to us, okay? If not, it's because we made a mistake multiplying both sides by x minus 5y and changing the domain of the problem. So this is derivative of the top is 2 plus dy dx times the bottom minus derivative of the bottom is 1 minus 5 dy dx times the top all over the bottom squared is equal to 0. So again, when we have a fraction here and it equals 0 on the right hand side, the numerator is 0, the denominator can't be 0, but I can write this as 2 plus dy dx times x minus 5y minus 1 minus 5 dy dx times 2x plus y equals 0. Just remember that x can't be equal to 5y, or y can't be equal to 1/5 x, if you want to say it that way, so that I can't have a 0 in the denominator. So let's go ahead and distribute everything here. I have 2x minus 10y plus x dy dx minus 5y dy dx minus, and then I have 2x plus y minus 10x dy dx minus 5y dy dx, and all of that equals to 0. So we have, I'm going to go ahead and move these two terms over right now to get rid of them. X dy dx minus 5y dy dx minus 2x minus y plus 10x dy dx plus 5y dy dx is equal to a negative 2x plus 10y. So negative 2x, when I add 2x to both sides to get rid of that, becomes 0. Going to add y to both sides. That becomes x minus 5y plus 10x plus 5y dy dx is equal to 11y. So I have 11x, negative 5y, and 5y goes away. Dy dx is equal to 11y. And dy dx is equal to 11y over 11x. The 11s will cancel. Dy dx is y over x. This is number 9. And so we have a substitution that we can make here, because it was possible to solve for y in the beginning, like I was showing you. And when we can do that, we should do that. So 6y is equal to negative x. Y is equal to a negative 1/6 x. And if that's the case, then a negative 1/6 x divided by x will become a negative 1/6. And I could have solved for this explicitly, like I showed you all the way up here, that this would have been very easy to find dy dx was negative 1/6. So don't just look at something because it has x's and y's in it and assume that you have to do implicit differentiation. Usually your instructions will say something along the lines of find the derivative implicitly if necessary, but you prefer to find the derivative explicitly if you can. So let's go ahead and finish up with number 11 here. Number 11 says 2y over y squared plus 3 is equal to 4x. So let's go ahead and differentiate implicitly, and we get derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom squared, derivative of the right-hand side. We're going to go ahead and multiply by that denominator on the right-hand side. That denominator can never equal 0, so it's legitimate to do that. Let's see, I need to add dy dx's here and here. Since I differentiated this y, that's a dy dx. When I differentiated this y, that's a dy dx. So this is 2y squared plus 6 minus 4y squared dy dx is equal to 4 times y squared plus 3 squared. So this is a negative 2y squared plus 6 dy dx equals 4 times y squared plus 3 squared. Dy dx is 4 y squared plus 3 squared. Pull out that negative 2. That's going to give me y squared minus 3. So this is going to reduce to be negative 2 y squared plus 3 squared over y squared minus 3. And we have our answer written a little differently here. Let's see here, derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom squared. That is, okay, so what the book did, which is neither here nor there. Nothing is wrong with what we did. It'll be numerically equivalent, but I'll go back and write it the way that they did, is they wanted to get rid of that fraction so that they didn't have to use the quotient rule. They would have preferred to use the product rule. So they said that they were going to turn this into 2y equals 4x times y squared plus 3, which is 2y equals 4xy squared plus 12x. And then we can take the derivative implicitly. 2 dy dx is equal to 4y squared plus 8xy dy dx plus 12. Let's get my dy dx terms on one side. So that's going to be 2 minus 8xy dy dx is equal to 4y squared plus 12, and dy dx is 4y squared plus 12 over 2 minus 8xy. Because these are all even numbers, I would reduce that myself to be this. To simplify it, the book did not. It left it as this answer right here, and that's fine. But when you see all common factors in there, you're going to want to simplify if you can. So there's the answer that the book provided and how they got it. All right. We'll come back next time and we'll find some slopes of these graphs that we have to find implicitly. So I'll see you for the next video.